Close.
Hello, this is Eric Williams, and welcome to the latest edition of our UCS Tech Talks. Today we're going to talk about our newly released Cisco Integrated Management Controller software, codenamed Eagle Peak or 2.0. I want to introduce my panel this morning. We'll start with Jeff Foster.
Hello. Hi all, nice to meet you. My name is Jeff Foster. I'm a technical marketing engineer at Cisco Systems.
And Rob Horner.
Morning, everybody. I'm Rob Horner. I'm a consulting system engineer with Cisco.
Awesome. And I'm Eric Williams. I'm a technical marketing engineer as well for Cisco. Again, we'll talk today about our Cisco Integrated Management Controller software 2.0 release. So let's first start with you, Jeff. I know we had a tech talk last month about the C-Series servers and its use cases around big data. But let's briefly recap some of those use cases about why someone would want to look at using a C-Series server for those who didn't attend last month.
Sure. So our C-Series run in two operational modes. One in UCS Manager under the Fabric Interconnects, which is what you discussed with Steve last month. And another operational mode is outside the management of a Fabric Interconnect, or standalone mode, where we're running each individual as discrete entities.
So what are some use cases of why you'd want to use those? I mean, besides big data, what are some other common use cases people use our standalone rack mount servers for?
It's just as much about use cases as it is about environment. So you mentioned big data, but in addition to that, some use cases that we see oftentimes is customers who have many distributed locations, retail environments, agencies, where you don't need to have a full data center setup. You just need to have a small number, say 2 or 3 servers at each individual site to run your cash registers, video surveillance, and any other applications to support on-site activities.
Yeah, that's great. So I know this particular talk is going to be really focused around C-Series servers that are managed standalone. Why would someone care to use a C-Series server outside of being connected to the Fabric Interconnects and managed by UCSM?
Yeah, there's a number of reasons, and I mentioned that last use case, which is a great example, where maybe it just doesn't, your environment doesn't make sense for you. You don't have enough critical mass, or you want to be able to manage each individual server as its own entity. We hear about air gap, for instance, where you have 2 physically separate systems with no shared components between them. So there's a variety of reasons why customers would want to run in a standalone mode or a more traditional mode. If you look at other vendors in the industry, that mode is actually very similar to what other rack mount server vendors have as well.
So for those who aren't familiar with our Integrated Management Controller, or CIMC or Cisco IMC, can you give a brief history of what it is, what's the basic functionality of what you have, and what we've done with the different versions in our 1.0 release train and what we're adding, and we can talk a little bit about what we're adding in 2.0.
Absolutely. So this is actually the 6th generation of Cisco IMC. There's a number of colloquial terms that we use. Officially, the name is the Cisco Integrated Management Controller, or Cisco IMC, sometimes referred to as CIMC. But we launched this with the product. It's a out-of-band management processor, or a baseboard management processor, that controls the critical functions that are performed both out-of-band and for server-side operations. From a historical perspective, I mentioned our 2.0 release is actually the 6th generation. We started with 1.1, and as we built 1.2, 1.3, and so on, we introduced new capabilities around monitoring, storage configuration. We added an XML API, and we actually had a debate long ago. When do we go to 2.0? And we felt that 2.0 was really a sign to the industry that this is a mature product, it's a fully featured product, and we debated whether we took the platform 2.0 in our last release, but decided there were some key features, and as you'll see today, we've got some very, very exciting features and some interesting enhancements to existing features in 2.0.
So really, it's just really putting a really focusing on making sure that people understand that this is a fully featured platform. We can fully manage their server, albeit doing BIOS configuration, RAID configuration, through a multitude of different interfaces, through our GUI, through our CLI, and through our API. So let's delve into the features a little bit about what we did in 2.0, and could you tell me a little bit about some of the features and enhancements we added to 2.0 that are quite unique?
Sure. So we've got a number of enhancements. In the case of storage config, for instance, we had the ability to do storage config via the graphical user interface or the WebUI as well as the CLI. So we added the ability to configure and manage storage via the XML API. We added networking capabilities. We added security capabilities, monitoring capabilities. We have a new KVM client. So a lot of our features are net new features, but we also have a number of small enhancements to increase usability or based on feedback or requirements from our customers. So we've really been listening to our customers, and I've already received a lot of very positive feedback in the last couple of weeks in customers who have enhancements that we've added here for them or for their use case.
So what platforms do we support this new CIMC or Cisco IMC 2.0 version?
So Cisco IMC 2.0 is supported on the C22, the C24 M3s, the C220 M3, and the C240 M3. Those are the current products that are supported today by this release.
And we'll be adding more platforms over time as we version this particular 2.0 release train.
Absolutely. So you'll see additional platforms supported by the IMC 2.0 going forward, especially as we release new platforms, or I guess the C460 M4 as well will receive this release.
Oh, great. So I think it would be good to kind of deep dive a little bit into some of these features. I think networking would be a good area to start with. You mentioned we did have some enhancements in that area. What are some of the key features that we added in 2.0 that we didn't have prior?
So three features that I'll pick on this morning are IPv6. So we've added IPv6 enhancements, Dynamic DNS, and the ability to ping from the web user interface are all new capabilities.
So let's take those in that order. What did we add with IPv6? What interfaces do we support using IPv6, and what are the capabilities?
Sure. So IPv6, I won't get into what is IPv6, but in the sense that we now support IPv6 IPing not only with the management processor, but also with all of the various interfaces. So if you want to configure SNMP or Syslog, we support both IPv4 and IPv6, and we support those concurrently. So anywhere that we specified an IP for a service or even the management controller itself, we now support a combination of v4 and v6 IPs.
So that means as I transition from an IPv4-based network to an IPv6 network, I don't have to just cut over immediately from an IPv4 naming IP scheme to an IPv6, and all the different monitoring protocols, like you said, SNMP, Syslog, as well as things like authentication with LDAP and Active Directory. We can use either or to do that configuration. Now, what about the GUI? Can I connect to the web GUI as well with IPv6 and IPv4 as well?
Yes, absolutely. So we're IPv6 compliant. That's one of the areas that we really wanted to make sure that we included in the 2.0 release, and actually was one of the drivers for taking this to 2.0. But yes, IPv6 really across the board support.
Now, what about Dynamic DNS? What did we add there, and why did we add that support?
So Dynamic DNS, we've got a number of customers that don't want to go in and manage their environments as they bring on new systems. So they just want to be able to rack and stack their systems, plug them in, have them IP'd automatically, and have the registration happen seamlessly. So Dynamic DNS, when you configure a system, it will actually auto-register with the DNS server, and the DNS server will be updated by the host. So any records in the DNS server will be updated. So that's another feature that we had an enhancement request come in, and it's something that we wanted to make sure from a usability perspective for those customers to include.
Now, what's the format of the DNS entry that gets added? Is it something with an identifier on the server, or is it pick a wild and wacky name? So
we've actually updated our identifier, and it is the C model. So in the case of a 240, it would be C240 serial number. That way, in the DNS server, you not only know the model, you know it's a Cisco server based on the model type, but you know the serial number as well. So you can identify that specific platform from the others that you've got. So that's something that we also wanted to make sure that we included in that new moniker, as you mentioned.
And we added ping from the CIMC as well. Why would we add a ping capability to the CIMC? What's the use case there?
The use case here is it will help you understand any firewall rules you may be contending with. So as you configure various services, you can ping to make sure you've got communication with those various services. So as you're configuring the CIMC itself or one of your underlying services, you now can make sure and confirm connectivity without having to go, especially in a data center environment, you go out to another system. Maybe you've got to walk a couple of racks over if you've got a platform that's in a DMZ environment, and you can access network connectivity directly from the WebUI.
No, that's great. That's great. I think this is a good set of features that we added on the networking side to really complete our CIMC implementation. Let's move on to storage. I know that's been a big area that, with 1.5 we added a lot of capabilities where we added the out-of-band capability to configure your storage, via the CIMCs, WebUI, and the CLI. Can you explain a bit about what we did differently and what did we enhance in the 2.0 to build upon what we've added in 1.5?
So I'll first talk about the WebUI, and as you mentioned, we did introduce storage configuration, the ability to create virtual drives in the WebUI back with version 1.5. And in 2.0, we enhanced that. So in 2.0, from the WebUI, you can now configure JBOD. So if you have a RAID controller like the 2008 M3 LSI or MES controller, we can actually configure JBOD at the push of a button from the WebUI. We can also clear and import foreign drive configurations from that interface. We can clear and set the boot drive from that interface. And we can also collect the log files for the controller. So all of that capability is now built into the WebUI, and we've also extended the XML API to support this as well. So
that means I don't have to go into the BIOS at all to go into an option or utility to do this. I can do this fully out of band through the web interface, through the CLI and the API to fully configure my storage controller.
Exactly. So in the past, a customer might have to go into Web BIOS and configure maybe not the entire controller with 1.5. Maybe it was just some element of the controller or get the log files. Now we provide that all via the WebUI, and we have everything that we support in the WebUI, we're now supporting in the XML API as well. So that's a key feature for us moving forward.
That's really interesting because that makes it where I don't have to use a KVM session to configure it or have to use a utility after I've installed the operating system. I can basically go to one interface and do everything, no matter what state that server's in. So we can. So you said you have the ability to create, drive configurations and such. What about, how do you create virtual drives in the through our different interfaces?
Oh, it's fairly straightforward through the WebUI. This is something that we added in 1.5 and the CLI as well. But in the XML API, we have a utility. It's actually an API helper that will help a customer in providing the proper syntax and context for configuring a virtual drive. So that way you know that you've got the right RAID specified, you've got the right physical drive specified, the right drive size. And then because it's XML API based, we are in the process of extending our integrations. So a great example is PowerTool, being able to not only configure the entire integrated management controller, CIMC, via PowerTool script, but being able to configure storage as well is now something that's within our capability.
So we've really extended the full hardware provisioning layer of these servers 100%, where you can configure the boot order, the BIOS settings, all of the administrative settings on the IMC for authentication and monitoring, as well as now doing storage configuration all through one interface through that API, which is pretty powerful, no pun intended. So I think this is a good place I'd like to see this. Do we have a demo that we could show, that you could share with us, showing these helpers and be able to show us the scripting capability with this new set of interfaces in 2.0?
Absolutely. Let me go ahead and pull up a quick capture that I did yesterday, actually, to highlight this capability. So we're logged into the WebUI here, and if I click over to the Storage tab, you can see all of the existing capabilities and the new capabilities that we built in there under the Actions list. Now, only those actions that we have available to us are highlighted in blue, so anything that's grayed out isn't actually available to us. You can see we've got a number of unconfigured good drives and no virtual drives configured. So think of this as a brand new system. And I'm going to go create a virtual drive from unused physical drives. So at this point, I can go out and I can create a RAID volume that's supported by this controller. So I'm going to pick a RAID 5. I'm going to pick a couple of drives here. I'm actually, I believe, going to select 6 drives, so 3 through 8. Select them. I'm not going to change the virtual drive name or the size. And this is the XML API helper that I mentioned a minute ago. So if I were using a scripting language of my own, or if I just wanted to push this out via a shell script that I've written in maybe curl, I can actually wrap this very quickly and know that I have a syntactically correct API call to configure the virtual drive.
So just to ask another question here, you haven't actually committed this yet. All you did is click the Generate XML API request. This is just, you went through the wizard and acted like you were configuring it, but all you did is click that Generate XML API request button, which would give you the XML API it would need to send from whatever SDK or toolkit you're using. You actually not applied this correct to the actual C-Series.
That's correct. So this is just an API helper. If you want to go out and you want to build 3 or 4 configurations, and a use case here, since we've been talking about use cases, is if I know I have a number of identical systems that I want to configure in such a way identically, and I want to go out and I can use this API helper to help me create the command syntax I need, and then I can build that into a script. So when those servers arrive in-house, I can then quickly provision them via a script that I've already written, and this API helper will facilitate that.
Yeah, that's really cool. I mean, because that makes it where, like you said, if you're building a big HPC cluster or something of that sort, or some sort of cluster where you have 50, 80, 100 nodes that are all going to be identical, you can truly create that end-to-end script that we talked about to configure the firmware, the BIOS settings, boot order, and now the storage, all through one that single API, and that's fully out of band.
Exactly. So if we move forward with the example here, I'm going to switch my screen over to a PowerShell ISE window, and you'll notice here in the ISE, I actually have on line 8 in particular, I've taken that information from the API helper and I've plugged it into a beta module of our PowerTool for IMC, and you can see that I've configured the drive identically with the exception of the virtual drive name, which I've called demo instead of RAID 3 through 8. And I'm going to run this selection. So it's going to ask me to log in. And you'll notice when we actually communicate with the API, this API call that you see on the screen, that's a very similar API call and now response that we would get if we were looking at the API helper. So it's very consistent, that API helper. It will help you if you want to create a script in PowerShell, if you want to create a script in Python, or if you want to create a script in some other language that you're working in. So very, very helpful there.
No, that's really interesting.
And so I'm going to click OK here, and then as we talked about before, I'm going to cancel out of this update, so I'm not going to commit it, but I had already committed it in a PowerShell session, and you'll notice that the name of this virtual drive is demo, and that's the delineation. So I wanted to be sure that you saw that that I actually had configured this via that PowerShell session. So that's a quick synopsis on our storage config, the XML API.
No, that's really, really interesting. I think that a lot of people are going to get a lot of use out of that capability. And again, it really gives them the end-to-end capability to do 100% of the provisioning tasks in their environment. I think it's also a really good segue to our next kind of topic that we want to focus on. It's around boot. I know in the past we've had capabilities to define the boot order in the IMC configuration, but it wasn't very quote unquote precise. You couldn't actually specify the different boot lungs you want to configure or the different network interfaces and such. We have a lot of requests for people to have the more fine-grained capability to specify my boot order. So I know we added a feature called Precision Boot. What's that look like, and what does this mean for a particular customer that wants a more fine-grained boot order?
Sure. So the first thing I think we should talk about here is a couple of concepts that we started using internally to help describe this concept. And those are first-level boot order and second-level boot order. So if you think about a traditional boot order, if you will, if you're in the BIOS and you're configuring your boot order, you can specify PXE, HDD, CD-ROM. And that's what we would classify as first level. So it will allow you to specify a boot type. So in the case of PXE, now the system's going to iterate through the network interfaces in the order in which those devices are enumerated. And we started thinking it would be great if I could take those network devices and reorder those. So I always could boot from, let's say, our lights out management or LOM port, and I could do that reliably. And so we actually started with the idea of being able to configure second level boot. And we decided, well, that's a great feature, but what if I wanted to configure a PXE device in the first position, put some other devices in the middle, and then maybe a PXE device for a separate network, for a separate environment at the end of the boot order. And that's where we get to Precision Boot. So Precision Boot is the interleaving of first level and second level devices such that each device can be placed very precisely within the context of a larger boot order.
Yeah, so you really don't have to group everything together like it used to be, where you could say, here, boot from network, but you couldn't specify exactly what to boot from, and then boot from a local disk, but you couldn't specify what type of local disk, SD card or a boot LUN or what have you. I mean, that's really interesting. How easy is this to configure? I mean, what's it look like to configure this for an end user?
I've got a demo here of how to configure a Precision Boot via the WebUI. So picture's worth 1,000 words, maybe a video's worth 1,001. So I'll go ahead and share this. So we talked about the concept of Precision Boot, and I'm going to use the WebUI. So similar to our existing systems, the configure boot order capability is under the BIOS. And you'll notice a slightly new screen here. So on the left, you'll see all of the device types, and it's broken out, so it's very granular. The screen is similar to what you've seen in the past, but you'll see the power of what we've done here as we configure this. So I'm going to specify a name for a PXE device, which I'm going to put in the first position. And I want it to be a LOM device, and I want that to be LOM 0. So I always want to boot from LOM 0 first. And then I'm going to say, if I have an HDD device, I'm going to call this boot as a backup. And that's from the mezzanine card. And then I'm going to pick a virtual media, and we'll call this DVD. So the DVD is only presented if I have a DVD mapped or mounted. So there's a placeholder for this device. I could pick the CD-ROM, or sorry, the SD card, and now we're seeing the power of precision boot, where I'm interleaving different media types. And the last thing I did is I've actually cloned that first device. So as you can see, I have the device in LOM 0, but I'm going to name it something different. So I can actually clone a device as part of this boot order configuration. In this case, I'm going to call it PXE2. And since I don't really want to clone it, I'm actually going to change the port to port 1, add this device, and it puts it in the first position since I've cloned it. But I'm going to move it all the way down to the end. I'll save it, and you can see the reorders happened. So at this point, I have my configured boot order here on the left and my actual boot order on the right. And as I go over here, I'll power cycle the system. And as we power cycle the system, the host, we will read this new boot order into the system, and it will reconfigure based on what we've specified. Now again, what you'll notice when we click over after the boot process completes here is that the DVD is not present. So we don't have a DVD mapped, but at some point in the future, if I were to map or mount a virtual DVD, either via the CIMC or the KVM, it would show up in the boot order here.
Well, that's really cool. I mean, it really allows you to, again, be very prescriptive on how you want to boot a particular server. Do you want to boot it, from a particular device and whatnot, and that's really specify the order in a very fine-grained manner. I mean, that's really awesome. I know we did some changes on our KVM viewer. What's new in that particular release? What did we add and change versus what we had in the 1.0 branch?
Sure. So there's a number of enhancements to the KVM window that we have, KVM client. So we have the ability to do chat. So if we have multiple administrators that have KVM windows open, they now have the ability to communicate between their interfaces. We have a DVR, so a digital video recording capability, so we can actually record the console. We have power controls right there in the top ribbon, and then we have a last crash boot capture, so we can see what happens at the time there's a system issue or a crash.
So on the DVR capability specifically, what are the different types? I mean, you said last crash and DVR capability. So I can basically get the last probably 30 to 60 seconds of what happened on that particular system, and that's a rolling log, or how does that capture?
Exactly. So that's a buffer, and it's a rolling log, and then in the event that you want to extract that, you can pull that down to your local system and watch it. So if you have a system that's gone offline for some reason, it will give you some indication of what was happening on the console at the time that system crashed or was powered off or ran into trouble.
So it's something that you can really give as a troubleshooting tool to either our support or another vendor support to say, here's exactly what happened during the crash, and gives the engineers that are debugging the problem a lot more insight into what was happening. Can you also do that for when a system's booting as well? Can you specify to capture data on post?
Yes, we can. So we have the ability to capture data on post and on crash. So in the event, as you mentioned, that the system's going to push log files up to the console, and by the time you see them, they're gone. Now you've got a recording of that, so you can go back and interrogate that data line by line to figure out really what was happening, and you don't have to guess what messages you might have seen at the console at the time you had an issue.
Now, do I have the capability to actually record what's going on? Like, let's say I'm doing an installation and I'm doing it through the KVM window. Can I actually do like a video recording and then save that and give to a colleague of mine when I'm doing a particular installation or configuration?
Yeah, so that's the DVR capability that I mentioned, where you can do exactly that. So if you have some sort of training or repetitive function that you want to or some information that you want to pass along to a colleague, you can certainly do that. So we have a DVR capability, and that will actually pull a file with the video that you're seeing on the console right down to your laptop. It'll save it off in a DVC file for future playback.
And that's not something that has a circular buffer. That's something I can record for an hour or 20 minutes right to my laptop or desktop or jump host.
That's exactly right. So from that standpoint, you're pulling that data stream right down to a repository that you've specified at the time you initiate the recording.
Well, cool. Do you have actually something we can see of what it looks like, what the KVM window looks like, and actually capturing some of that data?
Yeah, I've got a demo here on crash recording or crash capture. So let's take a look at this. I'll go ahead and in the CIMC you'll notice a new option under the Server tab for troubleshooting. So we talked a little bit about the bootstrap process recording. And we've got that here, so we've got the the recording enabled, and then right below that we have crash recording. We've got that enabled as well. So these are the circular buffer, or these are recording to circular buffer that we can then extract at some later point in time. And then just below that you'll see a player. So if you want to view the files in their native format, you can use the player. We also have an option to convert those. So we're going to capture the recording that we have on a system. So I have a server that's down. I'm not exactly sure why it's down. So we're going to overwrite the existing crash recording, and that will pull it off to a position in the CIMC where we can download it. So we're going to download that DVC file. And I'll flip over to the console here. And under Tools, you will see a number of options here that we've talked about, a number of these as new enhancements and capabilities. I'm going to go to Export Video, where I'm going to specify the DVC file as an input. So since I just downloaded it, I'll grab it out of my Downloads folder as the DVC. And I'll go ahead and put that onto my desktop as a .mov. And I'm going to change the resolution. I'm going a little blind here, so I'm going to change that to 1024 by 768 and export this. And this takes just a minute or two. Pretty quick process. I'll click Finish. I'll go back to my desktop, and you can see the video here. And I'll go ahead and hit play, and you can see we've got more than 30 seconds. So down towards the bottom, you'll see the counter counting up pretty quick here. So I'm seeing my console, nothing's happening. And then last night, it looks like somebody went to the system, clicked on power, and shut down the system. So now I know somebody was working on the console. Looks like they were doing some planned hardware maintenance on the system at the time it went down, or that's what they specified. So that's why my server's not up. Now, if I had a blue screen, or some other incident, maybe it was dumping logs to the console, I'd be able to capture that information as well.
Yeah, it's all regardless of what type of OS is running on it. If it's a purple screen, blue screen, a kernel panic, what have you, I mean, you can use it for all those types of things, as well as a good and detective work, like you can see there. It really wasn't a problem with the server, didn't crash, didn't power off inadvertently. Someone actually did power it off. So it's a good way to see exactly what's happened for the last 30 to 60 seconds or more in that environment. So that's really powerful. I think that because sometimes you need to get those particular codes or see exactly what was happening, to cause a particular crash. This is great. Are there any other features that are included in this release that we should have our customers and partners be aware of?
Yeah, so something that I deal with quite a bit. I get a lot of questions. Customers are always interested in monitoring their servers. It's something that as soon as you install the server, you want to get your monitoring system hooked up. So we have enhancements to SNMP, to Syslog, and to the fault engine from a monitoring standpoint.
So like specifically for SNMP, what things did we add for the end user to be able to configure and use with monitoring?
So actually for SNMP and Syslog, we included the ability to specify port. So if for SNMP, ports 161 and 162 are statically defined, and then 514 for Syslog, but some customers want to leverage different ports, non-standard ports. So we've allowed them, the field, to specify a different port if they want to use something non-standard.
Okay, so that really allows me to say if I'm going through a firewall and I need to send it to a different port to be translated through the firewall, or if I'm using something like Splunk, which likes to have their Syslog, Syslog messages being sent to a different port, I have the flexibility to configure that to what I'm specific for my environment. Did we do you mentioned some changes to the fault engine. What did we change specifically around the fault engine that resides in the CIMC?
In the fault engine, we actually have a history capability now. So in the past, when you looked at the fault engine, you would get a current snapshot of fault. So if you had a fault that was maybe a power fault, and you had somebody bump an AC power cord when they were walking through the hot aisle, disconnected AC power, but then it pushed it back in, and you received a trap. Now you can go back and you can see the history of faults. So you can see everything that happened on that system since the last time the CIMC was rebooted. So in the case where maybe you look at a system and there's no faults present in the system at the moment, now you can go back and interrogate what might have happened, do correlation analysis, or just determine, hey, maybe the tech was walking through the hot aisle at the time you had the fault show up.
Is that something I have to configure or turn on, or is that on by default?
It's on by default, so you get that capability out of the box.
Yeah, cool. To switch over to security enhancements, what are some of the security enhancements that we added in to the most recent version?
So we've got a number of security enhancements. We have what we're calling Secure CIMC, or Secure Cisco IMC, BIOS signing, and TPM Inventory. So those are some new security capabilities that we've added.
So what does Secure CIMC mean, and what does it mean to a customer? How do you configure it, and why would they use it?
So Secure CIMC will it enables us to certify the image that a customer is downloading and installing. So we have included signatures on our firmware, starting with MR2 or 153 release. And when we enable this capability, so it's an opt-in capability, we will actually validate that image prior to deploying it on the hardware. So that way you know you've got an image from Cisco, it hasn't been tampered with, and you can feel confident in installing it.
Is that for all types of firmware that we release, or just for the IMC itself?
This particular capability is just for the IMC, but I did mention BIOS signing. So that's another capability that we've introduced, where we're actually doing signature validation of the BIOS prior to installation and deployment.
That's pretty interesting. So that really allows you to start doing, really focus on having a very security conscious customer to have a lot of faith in they know they're running valid firmware that's been validated by Cisco and such. How does that enable things like a secure boot that Windows 2012 is introducing and other operating systems are introducing?
Yeah, absolutely. So with Windows 2012, we have introduced UEFI Secure Boot, and that's a capability that we will. So our BIOS signing will enable that, where we're actually looking at the bootloader signature at boot time. validate, I guess, that entire chain of trust from the CIMC through the BIOS up into the OS level.
That's interesting. So we really focused on, added a lot of things into the CIMC. I mean, really, all from storage to monitoring enhancements to some of the networking enhancements like Dynamic DNS and IPv6, as well as some of the security enhancements. Seems like Cisco did a lot of work to really add all of those elements in there and make it a very compelling management release.
Yeah, so all this together, as I had mentioned earlier, with 1.5, we had looked at, do we call this 2.0? And this brings together a number of new capabilities. So capabilities that are, for example, IPv6, Dynamic DNS, really enhancing the capability of the platform, as well as XML API configurability for storage and secure CIMC, and the KVM, which enhance the experience that a user has in deployment, management, monitoring of the CIMC. So it's a very, very mature product at this point, and has been for some time, but we finally decided that it didn't make sense to call this 1.6 and really not showcase the capabilities that we've embedded and the hard work that our engineering teams have put into this particular release. So across the board, there's actually a couple of capabilities that are even lower level than the ones we've discussed. So I encourage users, if they're interested in some features or understanding even more of what's in IMC 2.0, that they go check out some of the release notes. So that's all we had a chance to talk about and demo today, but there's certainly more goodness packed into that release.
So last question for you, and we're going to switch over to Rob, is around the integrations. I mean, with the APIs and whatnot that we've been developing against with System Center and VMware and PowerShell and whatnot, does Cisco have to totally redesign all of the integrations to take advantage of this, or is it just a couple additions in their coding to be able to take advantage of this?
More of the latter. So our API is additive in the sense that the capabilities that we have included here are small tweaks in the integrations. In fact, many integrations will continue to work with even this new IMC 2.0 release, but the model's getting bigger. The capabilities that we have to exploit as a common base with 2.0 is broader than what we've had in the past. But from an integration standpoint, because we've taken the model as it exists and appended it, it allows us to continue to grow those capabilities when it comes to our Microsoft integrations, PowerTool, Python SDK, and some of the newer integrations that we have as well.
So things like the storage configuration like we talked about, or things that we're going to have to add in to support to things like UCS PowerTool for IMC and System Center Configuration Manager and such.
Exactly, and it's right around the corner. So I showcased in the demo PowerTool for IMC, a release that I grabbed from engineering a couple of days ago. So as you can see, it's already working. It's working well in the labs. We're going through our testing of that. So that's what's enabling us to have that very quick release now. From a standpoint of when we release a new IMC version, we can go back, review the enhancements, and add some additional capabilities. And that applies to PowerTool. I think that's an easy example because we demoed it here, but applies to all of our integrations as well. So as we add those features, we're just really focused on taking the enhancements and exposing those enhancements to the integrations.
Well, thanks, Jeff. I'm going to transition over to talking to Rob. Rob, thanks again for being very patient. Let's sit on the call for about 45 minutes with us. But I want to transition over to talking with you to talk a little bit about, what your role has been at Cisco for the past couple of years, and first, and then talk a little bit about how you've used our APIs and IMC to work with customers that you've worked with in the past. So.
Yeah, absolutely. Good.
So I think first, what is your role? I know it's changing now, but for the past year or so, a couple of years, you've been a CSE or a consulting systems engineer working with our customers in the data center side, correct?
That's right, Eric. I've been working in the U.S. service provider data center group. We work with some of the largest service providers in the U.S., given the name. And primarily my focus in that group has been on automation. We have a lot of customers that are very interested in the new world of clouds. Everyone's talking clouds these days. As a matter of fact, that's my new role at Cisco as a product manager in that space. But I've been working with many of our large cable operators and telcos as they look to turn up cloud and compute environments primarily on OpenStack. And OpenStack, I think most of the people in the Hangout here today are aware of, is an open source cloud application stack, if you will. The thing that's really interesting, and you started off by asking, why would somebody want to do standalone mode? Well, in these environments in the open source community and these new cloud communities, there's a lot of focus on interoperable hardware. And you walk into very heterogeneous environments where you may see a lot of Cisco UCS, but you may also see some other vendor hardware as well for server side. And so it's very important to our customers that we be able to integrate with their standalone management systems at a level that some other vendors may be able to as well. So we can't always utilize all the capabilities and the breadth of UCSM, for example. And so in my one customer that I worked with most recently, we stood up two OpenStack data centers. They were based entirely on UCS 220s and 240s for compute and storage. And we had some unique problems that we needed to solve to bring things into operation. So if I could, let me go ahead and share kind of a picture of the problem that we were trying to solve here. Let's get that on. There we go. So in a deployment environment in OpenStack, you tend to have some pretty common tools out there. We use Cobbler for PXE booting boxes and installing operating system, kind of getting the generic OS up and running on that. And then once that's in place, then that hands off to a Puppet installer, which then goes through and loads the specific OpenStack instances, the particular agents, puts the configurations in place, and brings that box into production. But what's not being solved in this is this first step, where you have a server that you just stuck in a rack, you plugged it in, you powered it up, now what? Well, you have to know that, do I have the right firmware versions? Do I have the right BIOS settings? Do I have the right, is the boot order that Jeff talked about, is that correct? Because I may need to change my PXE booting on different interfaces. Are my drives set up correctly? Absolutely not. And so the problem we needed to solve here was integrating UCS into this inventory management system through a Pythonic interface, because Python's it's a pretty common higher level language that's used in these cloud communities. So what we ended up doing was, rather than utilize kind of the old style of interacting with UCS, which was through CLI, in which case a lot of our customers use expect scripts, and while expect scripts work very well, they don't always give you the full breadth of programmability that you need in order to manage these, the life cycle of these servers. And so I ended up working with a customer and writing a Python library, and I'm just going to switch over to it now. It's cleverly called PyCIMC. PIMC was taken. I was bummed about that. So PyCIMC, and this is out on GitHub. This is open source software available to the community.
So this is something that you wrote yourself, nothing that was based on any of the SDKs that we have developed at all. This is 100% developed by you.
That's absolutely right. Written from scratch by me, with some help from smarter Python people than myself. We did look at using there is an SDK that Cisco has for UCS, and it's a very powerful tool. It's almost too powerful for what we were trying to do. So we just wanted to do something I needed to do something very simple, very straightforward. But I also wanted to, go ahead.
It's something that fits more probably apt into an OpenStack environment. You wanted to build something more of a precision instrument or precision tool that really focuses on solving that element in OpenStack versus our Python SDKs really focus at being very generic and allowing you to do whatever you want to with it.
That's exactly right. There were really two use cases I had. One of them was to be able to write a couple of just generic Python applications to do very specific things like reboot servers in the rack or go get interface addresses. But we also, I mentioned Puppet earlier. Puppet, the way it's integrated into OpenStack, has there's a pretty common use through a CLI command. So it kind of expects to see a CLI. Well, the CLI expects to see passes parameters in and it gets back JSON data structures and it acts on those JSON data structures. So PyCIMC in part will also take these XML commands and then return back JSON, which then we pass into the Puppet systems. So just to give you a brief example, we won't go through all the code here. Basically, I create a class of UCS server, do different functions you'd expect to see. So I can log in, I can log out, I can set the power state, reboot, do things like that. I can get chassis information, I can see how my CIMCs are configured. But you'll notice in every one of these methods that what I'm doing is I'm passing a command string that looks mysteriously like an XML structure. So I'm actually, under the covers, I'm writing directly to the XML API using HTTP commands. So it's really no different than what Jeff showed earlier, where you did a curl command passing XML. I'm just doing an HTTP post with the same XML, and then I'm passing things like username, password. Later on, I get session cookies, and so I pass the cookie back in there.
Really what you're doing is just parameterizing the XML gets and responses that we've provided. Something similar to like what we did initially, myself and my manager wrote with Go UCS. It was just basically a very rude implementation of being able to take a parameterized XML file, ship it off to to the URI, and then parsing through the XML response that was returned.
Yep, that's exactly right. It's all pretty straightforward. And the nice thing about the way that the XML is structured in UCS is it allows me to write these really clean parameterized strings that I can then just go and create as necessary. So in this case, as Jeff showed earlier, that when he looked at the sample XML code for creating a virtual drive, I actually used that. I went into the GUI, did a test creation of a RAID drive, grabbed that XML that it came back with, and then just stuck in parameters where appropriate. So now I can take that. Let me flip over and do a live example here. And the caveat that everyone knows, the first rule of doing live demos is don't do live demos. So now I'm going to talk to one of my servers. Let me go show you this box. I'm on 200.100. I've got 2 drives that are unconfigured good. Everyone else is set up as RAID 0. So this is my customer needed to just go through the box and set every physical drive to a RAID 0 drive because they were using this for a Ceph storage installation. So I've got two drives that are unconfigured good. We go back over here. This is an app that I wrote on top of the library. So this is exercising all of those methods that I just showed you. Basically, we'll go in, query the box for all of the existing drive, both physical and virtual drives. If there are any physical drives that are unconfigured good, it will then take those and then turn them into physical or create RAID drives on top of them. So it's going to go out.
So you're going to log in here, you're going to get the inventory, find all the RAIDs that are not configured, and then create, with every drive that's not configured, create a RAID 0 set. So in this
exactly.
case,
so you'll see there's 2 unconfigured good drives that we just saw. It sees that my drive list is 2. That's all the details. I'm showing you a little more debug information than I normally would. But then it just creates a to-do list of go and configure 2 additional RAID 0 drives. Now, depending on the server and depending on there's some underlying things you guys could explain. It does take a little bit longer than I like sometimes, but it does come back typically within 30 seconds, sometimes as much as 8 seconds. But you can see it just created RAID 1, and then here in another 10, 15 seconds or so, you'll see the next one come back.
It probably just depends on how busy the CIMC is, if it's doing other things or dealing with faults.
Yeah, I've seen it anywhere from 8 to 30 seconds.
Right.
30 because I'm doing this live, of course.
Now, this is really interesting, though. I mean, it's
Yeah.
something that you could, as you add more drives into a server like this case, you could have this run on a scheduled basis to make sure you have all the drives configured
Yep.
and whatnot and such.
Absolutely. And you'll see that these 2 drives are now online. And then as it go back to the right. And then it went back to the inventory again, and you can now see all those drives are online, right? So a really clean, straightforward way to do this. And so that was one thing we looked to do. And I mentioned the the Puppet interface. The other thing that we needed to do was a command line. So to write a nice, clean command line for their automation systems, I wrote a little tool on top of this that, cleverly enough, is called CIMC. I probably should change the name of that. So CIMC simply gives me a command line structure to go query information on the box. So I can look at the management settings, I can look at the PCI bus, I can look at the interfaces. In this case, let me look at my power supplies on this .101 server. So it comes back, tells me I have 2 power supplies. They're both one's in operable state, one is unknown because I've actually don't have it plugged in. Right, so it very quickly gives me away, and you'll notice that it's all in a JSON structure.
Well, the interesting thing about doing that in JSON, it's really, the cool part about it is what we've done in the back end as part of our data definition layer. When we've defined every class in our XML API, we've done a really good job of defining all of the different properties and the data types, power supplies, compute motherboards, and DIMMs and whatnot.
Yep.
So the cool thing is all you're doing is really just translating that pre-existing data structure into JSON, and in some cases like this, you actually pared down some of the data to make it a little bit more usable for whatever tool you're sending it to.
Yeah, exactly right. And in some cases, like in the case of interfaces, the way the data model is in XML isn't quite what we wanted to see. We wanted something a little more hierarchical looking out of the JSON, so I'm actually doing multiple XML queries, gathering the data, rearranging as necessary, and then spitting that back out as, in this case, the way that the customer wanted to see the data.
You're basically creating your own data structure here. Where you're taking the data structure that we've already predefined, paring down some of the data, but then adding maybe a couple classes, pulling them together to make your own defined data structure.
Absolutely. And the key thing is, this was very simple to do, right? So the customer asked me, one morning, he said, "Hey, I want to go set the serial over LAN settings. I want to make sure that I've got that enabled." And then, like an hour later, he says, "Oh, by the way, do you have a way to change the admin password on the boxes through the CIMC?" And within a matter of an hour, I had the code up and running and back to him. So, utilizing the XML API, it was a very quick and easy way to go then modify this tool on top of it. So, it was tremendous win for us to be able to go in and give the customer that kind of automation so rapidly.
Well, and the thing is you're not a programmer, you're not a developer by trade. You just do this. You stayed at a Holiday Inn last night. Now you're figuring out how to, do this yourself. And that's it's the beauty of the API that we've designed it. It's not hard to write against. Even if you want to not use our own SDK, and you want to write something totally yourself. There's a lot of great modules and libraries you can get from things like from Python or Perl or PHP to be able to communicate, or Ruby and such. So this is really cool. And the nice thing is, just like you're showing on the site here, it's you have fully open sourced this, put it on GitHub under your site.
Yep, this is out there, open to the wild. As again, we should caveat, I have moved on to a new role in Cisco, so everyone listening can go ahead, download it, fork it, clone it, do whatever you want with it, expand it. I would love to see this, take on a new life of its own. I'm not really available to do any support on it, but it's as documented as it can be, and I hope this is useful. But again, the power that Cisco has put into the XML API in firmware 2.0 it's fantastic. It gives us so much flexibility.
No, this is awesome, Rob. I really appreciate it. Really appreciate your time, and really appreciate the level of effort that you've done to develop against our API. I think this is going to be stuff that people will definitely take up and use, and even if they don't actually use it as is, at least to steal your code in bits and pieces to be able to learn exactly how you're automating things.
Yeah.
So, again, we'll do a quick wrap up here. Again, I want to thank everyone for watching. Again, we will post the links of where Rob, put, on GitHub where his PyCIMC is available, as well as would love for folks to be able to continue this discussion on our community's website, communities.cisco.com/UCS. If you guys have any requests for future Tech Talks, please respond to our UCS Tech Talks pages on our community's website. We love to get feedback from customers on what you like, what you don't like, and those types of things. Is there any last words, Jeff or Rob, you guys would like to give before we close out?
So my only comment is Cisco IMC 2.0 is available today. So for those interested in trying it, head over to cisco.com and download a copy. And again, we'd love to hear your feedback out on the community site. And if you have anything like along the lines of what Rob's put together or something of your own, we'd love to hear that as well, and perhaps invite you out to a future Tech Talk. We've had a number of customers. We'd love to continue bringing new customers as well.
Rob, do you have anything you'd like to say before we sign off?
I think Jeff wrapped it up great. I really appreciate the support that Cisco has given us in this space. The tools just continue to evolve and get better and better, and it's really exciting to be able to use something of this caliber.
If a product manager can write some code, anybody can write some code.
Anybody can do that.
Well, thanks, Rob. Thanks, Jeff, very much for joining, and thanks for everyone for watching. I look forward to talking to you guys soon on the next Tech Talk.
Thanks, Eric. Bye.
Thanks, everybody.